So an example, the diagram shows part of the curve y is equal to 1 all over 1 minus x raised to 3. So we are asked to show that as p approaches to negative infinity, so this is approaching to negative infinity, the shaded area tends to a finite value, and we are asked to find this value. So it's moving to the p is approaching to negative infinity, so the direction, if we're going to trace the direction, it will be going on the left side. So it will be going on the left side. So the p is approaching to negative infinity. So the curve, so this is the given curve, and the limits, we have your p and 0. Okay, p and 0. Now let's start with the problem. So if we're going to write it, statement will be, so the area or the a will be equal to, so the improper integral from p to 0 of 1 all over 1 minus x raised to the third power, so dx. Okay, so first things first, we need to rewrite this so that we will be able to apply integration. So that becomes proper integral from p to 0. So we can write this as 1 minus x raised to negative 3. That will be dx. Now, let's start to integrate. So we're going to integrate. So this is in the form ax plus b raised to n. So this is not ordinary integration. So I'm going to integrate. This will be equal to, so integration from p to 0. So that will be 1 minus x. So negative 3 plus 1, that will be equal to negative 2. Okay, that will be equal to negative 2 all over. So we will have negative 2 here, and then the derivative of the inside. What is the derivative of the inside? So that will give us negative 1. That will be negative 1. So that becomes negative 1 times negative 2. Now let's start to simplify. So we're going to simplify this. Let's put a order. So that becomes proper integral from p to 0. So we will have 1 minus x raised to negative 2 all over positive 2. Okay, simplify. We can have it as p to 0, 1 all over 2 times 1 minus x raised to the second power. Oh, sorry. So we're done integrating this. Just erase the limits. Okay, we're done with the integration. So the limits will be on the left. So this will be from p to 0. This will be from p to 0. This will be from p to 0. Okay, so that's it. Now, so we're going to apply. We're going to have f of b minus your f of a. Okay, f of b minus f of a. So this will give us, so let's start with the 0. So if we're going to substitute 0, that becomes 1 all over 2 times 1 minus 0 squared. Close, minus, this gives us 1 all over 2 times 1 minus p squared. Close. Now, let's proceed. we're going to evaluate this. This gives us 1/2. Okay, this becomes 1/2 minus 1 all over 2 times 1 minus p squared. Okay, now let's try to analyze. Try to analyze based on the finite and infinite values. Now, so with this, we can say that as p approaches to the negative infinity, so based on the given here in the problem, that the p is approaching to negative infinity. Okay, so as p approaches to the negative infinity, so we can say that the one, we can say that 1 all over 2 times 1 minus p squared will be also approaching to 0. So therefore, since if this will become 0, that will become 0. So we can say that the shaded area, so we can say that, or we can just say that, therefore, 0, or just write directly. So this is approaching to 0. So we can just write directly that the shaded area, you can say that the shaded area tends to a finite value of 1 over 2. Okay, we can say that the shaded area tends to a finite value of 1 over 2. Or we can also say that, therefore, the improper integral p to 0, from p to 0, of 1 all over 1 minus x raised to 3 dx has a finite value of 1 over 2. So you can do it like this in statement form, or you can just write the given.